Will be better next time I try. And even if I still can't do it yet, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsies, whoopsie, whoopsie, whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsies.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard to follow the fight's too long. Wake up, my love, please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard to follow before it's too dark. Wake up, my love, please don't give up on me.
What is up? What is up, you guys? We are back at it again. Another day here in 100 Days of Rootkit. We're crushing it along, talking about the old ancient sea. Just like the Mediterranean Sea, it's still around. It still keeps things afloat, and it will for quite some time, alright? Except unlike the Mediterranean Sea, it can have upgrades, aka C++. But again, we ain't talking about that here. We're just diving deep into the original sea right now, so we can learn some big concepts, alright? Alright, before we go into that more though, let us first talk about who the hell we are. If you don't know, we are... Oh god, please, come on. Come on. What do you... How embarrassing. How are you going to tell me the site's down right now? Connection refused. Okay, well, moving on. We're a Rootkit nonprofit here in the US of A. I swear we're not too technically disabled, but I promise we do know a thing or two, even though our site may not be up right now. That's quite, yeah, big oof. That's right. That's right. All right. We're a nonprofit here in the US of A, and we're here to teach you for 100 days straight how to become a certified developer in Skip College. All right. It's not needed, not required. Colleges suck. They won't teach you jack shit, and employers know it. You will be unhireable. All right, unhireable. Ask any college grad. They'll tell you. On top of that, boot camps. Don't even mess with them. We're not even playing the same ballpark as them. They are just stealing your money. It's actually ridiculous. So just come. We're teaching you for free. Our cert's better than them. Really? You gotta think about it? It's an absolute no-brainer. Come on. Additionally, we have giveaways that we do on top of all this information that we're giving away already. Every week. We're on the week 9 giveaway right now, where we're giving away a mystery item. I don't even know what it is. We're going to figure it out this weekend, all right? We're going to figure it out this weekend together and randomly poll. Okay, ignoring this, all right, let me send over a ping to good old Taylor real quick. Site is down, but why? I don't know why. I was just on it earlier. Moving on. We have a link in the description of the video and somewhere in the Twitch bio. If you like what we're doing and you would like to help support us, hey, it's expensive to do stuff for free. So you can donate, and all donations are being matched 1-for-1 for the first 10,000 donations. When you donate, you can unlock certain merch, like our epic stickers, our collab t-shirt, and this epic sweater I got on. It even says Rootkit on the back, all right? On the way, we have pillars like teaching for 24 hours straight, shaving my head here live on stream, and shaving my beard, which no one wants to see. So our goal is not to hit that goal, all right? That's a good goal to have. So, trekking through, Dave, is it Dave? Wait, did I mislabel this? Is it day 58? Oh, God, we're all messed up today. I swear, we get through like 7 days straight before something happens. Mic is muted, camera's off, sight is down, something. You know, something always has to go disarray. But that's okay. Just like our theme song, oopsies, alright? Oopsies are okay. Alright, it ain't hurt no one. Alright, the stream goes on. We still teach. Just little oopsies here and there. Is whatever. So, today, we're going to continue on learning about C, how every language is basically the same, and getting ever closer to the headache-inducing concept of pointers. Not really. Pointers are an easier concept to understand, I think personally, than classes. But everyone's different, all right? A lot of people think it's cancer. We'll figure out, but it's important for you guys to know because it is relevant for every language. All right, it's a very important concept to know and understand, and we'll hit on some data structures because data structures in C way better than doing it in Python. Doing it in Python is kind of a joke. All right, I'm gonna be honest. Look, every language has its limitations. All right, every language has its limitation. You use the one that is best suited for completing your task. So, before we get forward, I'm gonna check chat, see if there's any questions for the last couple days that you guys would like answered. I don't see anything right now. Drop questions in chat anytime you would like. Additionally, I'm over in Discord's event chat, so you can ask question at any time. Jump in there if you are a Patreon premium member. Patreon member or Discord premium member. Did you do something different with the YouTube stream? Because lately it's different. Different how? So the video, oh, I did not do that. I actually just noticed that yesterday. And I'm not quite sure. It must be a YouTube thing. I'm not quite sure why it's doing that. It literally must be a YouTube thing because I have not changed a single setting on YouTube for doing live rewinding. So who knows? All right. So recap of yesterday. Yeah, like I can't go back 10 minutes to check something anymore. Yeah, I know. I just noticed that yesterday because I was trying to go back and I couldn't. Can't do it now here. So I'm assuming it's a YouTube change. All right, but everything's exactly the same on my end. All right. So recap. Yesterday we covered variables, how to create variables in C. All right, slightly different. All right, slightly different concept than Python, but it's the same at the end of the day. You make up a name. It follows the same naming schemes, all right? Except you have to specify what the variable, what type of data is going to go into that variable here in C, and it's only allowed to contain that data. It's not allowed to contain any differently formatted data. Asterisks on that because at the end of the day, all data is data, so it's basically how it's being interpreted when it's put in here, all right? We went over printing. It's called printf instead of print, all right? And to print variables, you're always in a format-like state. So how Python has .format, you have basically the same thing here, except you always have to use it. And instead of just doing brackets, you have to do %sign and then something following it, all right? %sign, something following it. Usually it's going to be the name of the variable. So I for int, U for unsigned int, F for float, C for char, S for string, and for booleans, you can print it out as an integer. Signed or unsigned, they both shall work. And it gets a little crazy when you start doing longer sized variables like longs, which are going to be ZU. Alrighty. And we have arrays. There's no concept of strings, there's only arrays. All right, only arrays. That's why they're called strings, because you string together characters. Yeah, same kind of annoying. Yeah, YouTube must have definitely changed something. It is more annoying, but maybe they think, yeah, maybe they think that does make them more like Twitch, all right? Which is kind of cancerous, because I don't like Twitch that much, all right? But we shall progress, all right? So we had this cool file, super awesome. Let's make another file, all right? If you're in Visual Studio, you'll go over here to the side panel here, and I still don't think, okay, hold on. Before we move forward, let's Google and figure out how to make everything bigger. Visual Studio, zoom in. This has to be Visual Studio Code, right? Because that doesn't work. It's saying control, because like this code's big, but this is super small and it's hard for you guys to see. And then this stuff down here is small and hard for you guys to see. One last look before moving on forward here. I would imagine there's some type of, why you gotta do this to me? See, okay, this is a personal pet peeve of me, all right? Because Microsoft historically has been trash, uncomfortable, not good at design, just absolutely cancerous. No one wants to use their stuff. But they still always had a cult following because some people would just get super deep into it. Then they released Visual Studio Code, which made no sense because it was great. It was beautiful. it worked great. It looked fine. Like, and then you get back to normal Visual Studio, which is still kind of garbage. All right, pretty hot garbage still. And it doesn't make any sense. There's no like nice standard smoothness. Like, I don't know, if you're on Mac OS or something, you know, it looks the same. iOS, Mac OS, it feels the same, it functions the same, everything's where it's supposed to be, the shortcuts are the same. But on here, the commenting shortcut, for example, I ran into this last time we talked about C and we were in Visual Studio. I can do control question mark or control slash over in Visual Studio Code. That will comment and uncomment code. You can't do that here. You have to do control KU, I think. Control Shift K. I don't even remember now. It's cancer. It's so stupid. Microsoft is literally the stupidest company sometimes. Actually, predominantly over the last decade, they've been the stupidest company in the entire world. All right. I don't know why, but recently they've been starting to turn stuff around. Their .NET platform has been pretty baller. All right. It's been pretty epic what they're producing over there. So hopefully the rest of this ugly situation and the idiots they have running it will be replaced with whoever's taken over and conquering at Microsoft, because it's pretty ridiculous. But we shall move forward. We shall move forward. So over here on the side, it's really, really small, but there's a folder here at the bottom called source folders. Go in and open that up. You're going to see your file here. It's going to be called .cpp. Why is that? It's C++. Even though we're not programming C++, it doesn't matter. All right, it's just labeled as C++. We can go and make a new item here, right? New item. So you're going to right click on this, add new item, and we're going to call this, I don't know, let's call it ifs. All right, ifs.c.pp. All right, that will open up a brand new file. All right, and you'll see here at the top, you can switch between the files, and on the side, you can click on them. For Mac OS, it's going to be pretty similar. All right, it's going to be pretty similar. I don't think you guys really need my help. Your file stuff is going to be on the other side over here, and it's pretty much just as easy. Just make a new file. All right. Once we're in it, all right, it can be called .c or .cpp at the end. Both will work. All right. So we need to make our file here. It's easiest if we just steal some of the code here from our previous one. Oops, grab this, pull it over, paste, bam. All right, all we need is standard IO. We need our main function because by default, it doesn't know what to execute. We need a main function and we need to add that ending curly brace. All right, to make sure everything works, we can go and do a printf in here and say hello. And then make sure you have your semicolon and you can go and run this. And if it works, you should see, why do you gotta do this to me? Multiple lines define symbols. Why cool string? Okay, why are you doing this? I want you to execute this file. Oh God, it's executing the other one. All right, so what we can do is think about this. Great question. Can I just, there we go. Will that fix it? Close that, run it. Why you gotta do this to me? I thought I could just run this crap. Oh my gosh. Okay, what we're gonna do is instead create a new file. Call this day one. Add it. Copy everything over from intro to C or your original file. Paste it on the other one. Close that out. And then on the OG one, we're just gonna start anew in here. All right, we're gonna start a new one here, so I don't have to sit here and mess with the Visual Studio stuff because I don't really want to figure this out right now. I want us to keep going forward. right click the file name, new file. Keeps asking for a template of the new file. Then, okay, let me pull out the Mac. So, it should be pretty simple, you guys. It should just be add new file. Alright, it's literally, so make sure you're on the files tab. Make sure you're on the files tab. Right, it's going to be the last little icon with the folder. You're just going to right click, new file, and then what type of file are you making? I just told you, you're making a C file. We're working in C, right? So when it says ask for a template, come on, we're in C. We're using C, so click on the C one, right? Once you click on the C one, it should just ask for a name, which it does. You can auto create the header file if you want. That's fine. We'll get into C or C++ will both work. C or C++ will both work. The header file you can auto create, not that big of a deal right now. We'll get into what header files are later. All right. So let us continue on. So now if I do a print f, oh God, why you gotta do this? Hello, and add the semicolon. Does this run without being okay? We're playing this game now. I think it just wants me to resolve the errors. Is that what it was all along? I just need to resolve the errors in this day one crappy code. Oh, truncated main already defined. Oh God, okay, maybe that was it. Maybe I got preemptively angry at it. My cool. Okay, you know what we're gonna do is X unreferenced. Where the hell is X at? I know it's unreferenced. Must return a value. Return 0. Are you happy now? Main already defined an ifs object. Okay, let's delete this file. Now I messed it up. All right, there we go. Whew. All right, I think we actually had it right at first. I just didn't take a second to read the errors enough. So it looks like it's working now. I had to change the name of this main because, like I said, it will auto find the main and then execute it. All right, it will auto find the main and execute it. So just add something else here. So that way there's only one main. All right, and this one I deleted completely. So there's only one main. When you run it, it should just work. It should print hello. All right, I'll give you guys a second to figure this out. Yeah. Let me open this window because I'm dying. What a rough start today. What a rough start indeed. First the site's down, now this stuff. All right. Let's make it a good rest of the day though. All right, good rest of the day. So hopefully y'all are caught up now. I don't see anything in the chat. Again, make sure there's only one main function, so the other main function just add another character or something to it. So there's only one main. Make sure it's completely empty, right? Make sure it's all completely empty. C++ is fine. C++ works just fine. Yes, they're completely compatible with each other. Don't worry about it. C or C++ both work just fine. All right. So, chugging forward here. We're going to talk about if statements. All right, we're going to talk about if statements. We have if statements in Python. You're right. Congratulations. That's pretty much the same logic for every language. All right. There are going to be if statements for pretty much every language. How do you do an if statement in C? Great question. You're going to say if. There you go. Now, different syntax here because Python is a white space sensitive language. All right. So the spacing you use is important, and that's how it knows when things are supposed to execute, not execute, what logic it's supposed to evaluate, not evaluate. In C, we don't know. So we have to be more explicit. So for your if statements, your elif statements, and your else statements in C, the format is you say if, then you do your parentheses. In here is where you do your logic. And then after that, you do curly braces, and inside the curly braces, you put whatever logic you want to execute. This syntax I personally like because it's a little bit easier to understand, especially as a beginner, on what code is supposed to run when. Unlike Python, which can be kind of confusing at first with the tabbing. All right. So tabbing here does not matter at all. You don't have to have your code tabbed up. It looks nicest when you do that, but it's not required. It's only required to be between these curly braces. All right. So to make an if statement here, it's just as easy as Python. We can say if 1 is equal to 1, then do some logic. All right. And you put the logic inside of the if statement. Alrighty. So let's go ahead and print 1 is equal to 1. Wow. All right. Very simple if statement here. All right. So if we run this, this should be true, and we should see this print statement go out. If we run it, you'll see it's true, and we see this print statement go out and appear here. All right. We see hello, and then 1 is equal to 1. Wow. All right. So I'm going to add a new line here. I'm going to add a new line at the end here. Printf and new line, and make sure I do that semicolon, so that way we get a little bit nicer of a output. And then same thing if it's not equal to. So if I put 1 is equal to 0, this is false. This is not a true statement, so this if statement will no longer print out. So if I rerun this, you'll see it no longer prints out. We just get hello, and that is it. If statements, you've seen them before. You've done them in Python. They work exactly the same here. There's no new trickery, right? No new trickery. The only new things is in Python, you can use the words and the words or. All right, you can use the words and you can use the words or. In C, you cannot do that. You cannot do that. It does not work the same way. You have to instead use double ampersand for ands and double pipes for ors. So you can say 1 is equal to 0 or 0 is equal to 0. All right? Or 0 is equal to 0. This will work. Did I intend to do a bitwise? No. So if I run this, you'll see it works, and then we get our printout here, right? We get our printout here. And then if we did the ands, all right, double ands, you'll see it will not work, so we don't get our printout here, right? Double ampersands for and double pipes for or, right? Double pipes for or. So let's go ahead and leave a comment here so we can always remind ourselves for and double pipes for or. Pipes, again, are going to be typically above your enter key, all right? They're literally straight up and down. Straight up and down. Any questions so far? Is there something like a code translator, kind of like Google, lol? Type in Python code and have it translated to another language. If not, there should be. Yes, it's called Codex. Remember that thing I showed you guys? It's brand new, made by OpenAI. Yeah, you can use that to translate code from one language to another language. And it does it pretty decently, to a certain point. All right, it does not work with everything. It works with very simple programs, so you can do that. Besides that, not really. There's some stuff, there's been some attempts by some people, and it works to an extent, but yeah, there's not really a use case for it in most cases. Well, that was just typing in sentences. No. Codex does code. That's the whole thing I showed you guys with auto documentation. Does anything with code. Not ChatGPT. That's the shitty version of OpenAI's GPT product offerings. All right, that's the consumer grade. You show your friends, you make memes, everyone on the media shows it off. Normal GPT and Codex are the hardcore, big boy, commercial grade ready stuff. That's what you want to be using. All right, you're a dev now. You don't go for the low end consumer grade stuff that you flip and sell for insane profits and get everyone to pay for it. All right, you go for the big boys, the heavy duty, the artillery, so you can get some real work done. All right, real work done. All right, so let's see here. We got our if statement. All right, now just like Python, there are else if statements. So in Python, they made it so it's called elif, not here in C. You spell it out completely. It's called else if, right? Else if. Elif is short for else if. All right. Same formatting. You need parentheses, and in the parentheses is where you put your logic, and then you need curly braces after it, which is what you say what should execute. So if we do print f, this is the elif. All right. And let's go ahead and make a variable here. Let's say tacos are good and equals true. And remember, we have to specify what type of variable it's going to be. This is a Boolean, so we have to say bool. All right. So bool, tacos are good. So we can just put that in here and put that in here. And let's say this is going to be the opposite of tacos are good. So in Python, to do the opposite, you would say not space and then what your variable's name is. Is this a thing now? I'm not going to trust it. In C, you can do not also. That's going to be the exclamation mark. The exclamation mark is your not operator. All right, your not operator. It looks like not may work. I don't know. I personally have not used the word not. So use the exclamation mark instead. So if we run this, this is true, which means this will be executed. This if statement will print out. So we will see 1 is equal to 1. Wow. Even though we're not doing that anymore, we're talking about tacos. So let's go ahead and run this. And you'll see that it says 1 is equal to 1. Wow. Now, if we were to change this to false, this will no longer print out because this is no longer true. But this is the opposite. So the opposite of false, so not false. This is now true. So this will now print out. So if we run this now, we should say, see, there it is. This is the elif, right? This is the elif. And just like Python, right? You can have infinite if statements. You can have infinite elif statements. You can only have one else statement at the end of a if block, all right? So again, well, technically only one if for if block. So one if for an if block, one else for an if block, infinite else ifs, but you can also have infinite ifs that start new blocks, all right? That start new blocks all by themselves, all right? And this can, again, spacing doesn't matter, so you can put any weird amount of spacing in between everything that you want. Does not matter, right? Does not matter at all. So how do you do an else? Great question. You just type in else and then curly braces, right? Else, then curly braces. And then we can say print f anything else. put our semicolon. We currently have no way to get to this. Well, we would if we remove the not here. So let's just remove that not here for a second. So both of these need this to be true. Since this isn't true, then this else will print out. All right, so if we run this, you'll see anything else gets printed out, because if it's anything else, there you go. To make this more appropriate thing, we can do something like int my fav num equals, I don't know, 8. So talkers are good. Whoops. And I'm already messing up with my Python stuff. And my fav num is equal to 5. And we'll copy this over. And my favorite number is equal to 3. And then anything else. So this is going to be more of a traditional logic statement you'd see. So if tacos are good and my favorite number is 5, then we'll print out this. If tacos are not good and my favorite number is 3, we'll see this get printed out, or else we'll see this get printed out. And since my favorite number is not 5 or 3, we're going to see anything else get printed out, and we see that get printed out. All right, anything else? Let me double check chat here. Where did you place the return value from the day one? Put it at the very, very end. This is just like a return in Python. So just put it at the very end. You can just do return 0. Return 0 means everything ran just fine and functional. Anything above 0, it won't ruin anything. It won't break anything. But technically wise, it means that you ran into an error. All right. We'll maybe talk about that later, because this is applicable to all programs. It just says build failed. Shake my head. Doesn't give an error message. It does give an error message. How am I supposed to find what out? Yeah, post. Okay, let me pull up the Discord. Looks like it ran to me. Click on the, okay, at the top here, click on the red error, and that will show you the error message. Most likely it's not an error in this file because this one looks fine. Most likely it's going to be an error in your main. All right. So, if statements, you've seen them, you've used them, you've interacted with them, we've messed with them a lot. They should be pretty self-explanatory by this point. We've talked about them in basic math. We've revisited them over in computer hardware. I'm forgetting the name of the module now. Where we talked about, it was with Taylor for you guys, where you talked about NANDs and all that gate logic. All right, you saw it there again. It's the same thing. We saw it in Python. You're seeing it again here in C. All right, it's the fundamental fabric of all programming. So we're not going to go into this much more. Same thing with parentheses, just like in Python. The first set of parentheses are required to contain all of your logic, but you can add infinitely more parentheses inside of it to force things to execute first before other things execute, just like you can in Python, right? Just like you can in Python. So that is something you can do. All right. Moving on here, let's see. We're going to do inputs, ifs, and games in C. So let's talk about input a little bit. All right, let's talk about input. In C, this is not even including C++ because there's even more ways in C++. In C, there's 1,000 different ways you can get input from the user. Some ways are better than others, period. There are some ways that are just straight up better than others. Why? Because of security. There are some ways that will straight up introduce exploits to your program, and you shouldn't really use them ever. All right. Visual Studio is really nice because it will try to make you, or it will force you by default to use the more secure version of C functionality. A lot of it is Microsoft's own take or own version of it, but they will actively try to stop you from making bad code that will destroy everything. All right. So there are a bunch of ways. I know Python, there's only really one way. There's input. That's the only really way you can get input in Python from the terminal. In C, it's not the case. There's lots of different ways. So we're going to talk about two of them, right? We're going to talk about two of them right now. The most popular used one is going to be scanf, and I think it's not going to, I think there's a Microsoft specific version we'll see here in a second. Scanf should look kind of similar to its layout as printf because they're pretty much exactly the same. What do I mean by that? In our printf, all right, in our printf, we're going to have printf, our string with, you know, the %sign stuff, comma, our variable, right? Comma, our variable. It's the exact same format for scanf. What's inside here is going to be text you print out on the screen plus what you want to get from the user, right? Plus what you want to get from the user. Then it's going to have the variables that you want to store that data in, all right? Now, this can be potentially hazardous for multiple different reasons, all right? Multiple different reasons. So let's go ahead and see some of those reasons right now. If we want to get a string of characters from the user, we can say %s, because that's how we print a string, right? Well, that's how we can ingest a string here using scanf. All right, then we'll say comma, and what variable we want to store it in. Well, right now, we don't have any variable we can store a string in. All we have is tacos are good and my fave number. All right, so to store this variable, we need to make a new variable. All right, we need to make a new variable. So to make a string per se, we'll need to say char and say my cool string. I'm just going to say my string. All right, and we need to say a length, because remember, you can't make just a string. You have to specify how long it needs to be. So let's say 5. It can be up to 5 characters long, which is a lie. Why is it a lie? We went over this yesterday. It's very important for you guys to know. The last part is always reserved for that null byte, or should always be reserved for that null byte. All right? Especially if you're going to be printing this. If you're replacing that null byte, you're going to run into issues. So technically, we can only write 4 characters to this string. So if we say my string and we drop it in right here, all right, looks like we're good. I know it's going to be complaining here a little bit. You can ignore that for right now. This should be getting a string from the terminal. To see this, let's just print it back out. So let's do a printf %s, comma, my string. Literally the exact same formatting as scanf, except as printf. One is for ingesting, one is for outputting. So let's go and run this and see if it crashes and burns, which it is going to. There we go. This is what I expected. So as you can see here, if you're in Visual Studio, you will get this error. If you're on Mac OS, you will not get this error, right? You will not get this error. Scanf is a pretty unsafe function to use. You can use it. It is bundled with a lot of old functions that are unsafe to use by default. Why is this unsafe? Because we want a string that is of 5 long, and we don't want to replace that null byte. But scanf will by default allow for the user to input just about everything, and it will try to shove it into that variable, including possibly overwriting the null byte. Additionally, you can shove in malicious code really easily and mess up a lot of things in your program, yada yada yada. It can be potentially very dangerous. So much so, Microsoft doesn't even like you using it. All right, there is a way to disable this protection, but we're gonna move forward and use the secure version, right? The secure version of it. It's important to read these errors and see what is going on. All right. But like I said, C doesn't get rid of the old, unsecure, crappy stuff. Anyone could use it. You, learning C right now, could use scanf. Pretty much every tutorial on C online is going to tell you to run scanf. It will not tell you about how terrible it is security-wise. All right? It is so bad to the point where this is a relatively new feature. Microsoft is doing this. The securer version is going to be scanf right here, according to Microsoft, scanf_s. They did not remove scanf. It is legacy code that is potentially exploitable, included with every copy of C and everywhere. All right. Windows's fix is introducing this _s concept, right? _s concept. If we save and rerun, I think we have to add, no, that's going to work. All right, so now it's going to work. Thought we would have to add one more thing here, but I guess not. So _s is supposed to be the more secure, less exploitable version. So now when we run, it is going to work. We're going to see this little output, this little cursor here, right? That's our input we need to give it. So let's say something like hello. Interesting. Hello is 1, 2, 3, 4, 5 characters long. Our string can only handle 5 characters. It has no room for the null byte. You're correct. Let's see what happens. I press enter, and it looks like it freaked out. Why do you freak out? I think it didn't. I think the secure version just didn't even let that be written to the string. So let's do that again with just a he. Nope. Doesn't even like that. Missing integer argument for scan_f. Okay, that's what I thought. I don't know why you wouldn't error out. Oh, to the Microsoft Docs we go. Format arguments. I think it's because it wants this. Why you gotta do this to me right now? Missing integer argument to scan_f. That corresponds with conversion specifier 2. Constchar %s. Why are you doing this to me? Oh boy. This is gonna be a rough one, you guys. That's what it wants. Okay. No. Well, the error went away. Doesn't want this again. Why you gotta do this to me? With conversion specifier 2. This is literally char s. I think I had an issue with this last time because their docs were incorrect. Well, this is I'm a kill Microsoft. I'm absolutely just destroy them. So irritating. That's what I thought, but it doesn't even say that. Yeah, I freaking hate them. I hate them so much. Okay, let's go back to the stream and let's catch you guys up on what just happened there. So like I said, Microsoft Cancer, right? Typically in C, you'll see there's a normal version and it's called a stern version of it, which is going to be with N, and that's specifically because you have to say how long the data is. So what it was saying here, which I don't know why it wasn't showing up when I hover, okay, this is how bad the docs are, right? This is how bad they are. We go right here, official Microsoft Docs for scan FS for the strict or secure version. It wants that variable or the format. So this is the string and then arguments. Doesn't tell you anything here that it wants the length. It kind of does in the error, but not really. I absolutely hate this. All right. So yes, correct, Kamal. You will do a %i for an integer value. That is, you're ahead of game. You're catching on here real quick. All right. So I don't think I need the 3 here then anymore. Okay. So the format for scan f_s is going to be just like the print one, except one additional argument here at the end. And do I need, I think the ampersand's, no, the ampersand's not going to be needed. All right. So same thing as printf, except you need to add one final argument here. And this is going to be how long the input is allowed to be. All right. Because the problem with the one before, the unsecure version, is you can type in any value and it's going to shove it into that variable, potentially replacing the null byte, like I said. When you use scanfs, the secure version, you have to explicitly say how much data you are allowing to be inputted, period. So they cannot overwrite that null byte. So for example, our string is 5 here. We want it to be 4 here because we don't want to overwrite that null byte. So when we run this, if I put in a super long string of potentially malicious code and press enter, you'll see that it doesn't like that, and then it errors out. So it's not going to like that. It's going to error out. It's going to be very mad. Let me do a new line here and rerun this. There we go. You can see it's not very happy. It errors out. It doesn't like it. I think, yeah, there we go. When we follow the rules and we do exactly what it's expecting, then it's going to be happy, and it's going to, sorry, I'm rerunning this a lot. It's going to be happy, and it's going to output what we have here. All right. So you need to be explicit. Boolean is not %b. You can just do a %u, and it's going to be a 1 or a 0, because remember, Boolean is just true or false, aka binary 0 or a 1. So they need to enter a 0 or a 1, and then you could put that into a binary value. Are you all using different information systems? Is that why it would still work even though what you entered is different? Yes, the operating system plays a factor, because like I said before on the intro of this, every operating system is different and will handle things differently. This specifically is the compiler. This is a Microsoft compiler, and the compiler is what turns this into binary code. The Microsoft compiler will handle different code than the normal GCC compiler. The GCC compiler is what comes with macOS and Linux. GCC, that's going to be your GNU compiler collection. Any documents that you read are going to be on this. All right. And also, I should bring this up, for when you're using macOS or you're using Linux, for example, I'm using Ubuntu here. We talked about man pages. Remember those? And we talked about man pages have the potential to hold different versions of the same functionality. All versions of Linux, asterisks on that, pretty much all versions of Linux and macOS will have the man pages for the entire C library and C++ library. What does that mean? I want to learn more about printf. I don't need to Google it. I can say man print F, press enter, and guess what? I get the output of printf. This specifically is going to be the user command printf. This is not for C, all right? This is not for C, because remember there's different versions of each page. This is page 1 of printf. So if we do man printf, and I forget which one it is. Is it 3? This is for the user command. Let's do 4. Let's do 5. Am I putting in this number in the wrong place? I don't think I am. 6, 7. Gosh. Okay, whatever. Let's do scanf. Man scanf. This will tell me what page it's on. Okay, maybe you don't have scanf. Are you kidding me? Does this Ubuntu not have it? I swear to God, they literally all have it by default. Regardless, you can use man to bring up the man pages for the commands. Here we go. This is going to be I believe it's going to be a library call, which is going to be 3. I thought I did 3 first. So 3 and 2 would be your answers for most of these. Is it for 2? No, it's just not even included in this one. That's ridiculous. Okay, whatever. We're moving on. This output kind of covers, even though it's not the official Linux one, it's pretty much covers exactly what the C function is capable of, and all of those % stuff that you were able to see before, and the special characters you can utilize. All right. So let's go ahead and move on forward here, shall we? All right, just checking, seeing if there's any questions. All right, so we're able to get input from the user now, and we're able to output that input. This, usually when you take input from a user, it will go into a variable people will call the buffer. All right, and this is where you get things like the term buffer overflow, because it's typical to make a buffer, because a lot of times you don't know how much data might be given to you. So there's ways to go about it. There's intelligent ways and there's not as good ways, but sometimes you need the not as good ways to go about it. So not as good way would be, I want this to be my buffer, so I'm going to call it buffer, you know, whatever you want, and I'll say something large like 128. And because we're programmers and we don't want wet code, right now this is wet because anytime I want to change this buffer, I have to go in here and manually change this. I don't want to do that. So what we can do is we can say size of our buffer, which is going to, every character is 1 byte in size, which corresponds with this. So this is going to be 128. We don't want to replace our null value, so we'll do -1. All right, so 128 minus 1, that is going to be our dynamic size of our buffer here. Let's go ahead and save this and run, and now it's not liking because this is no longer my string, it's going to be my buffer. So now we can handle a large amount of data. All right, so if we press enter, we can see now we can type more freely, and we can enter more data up to that 128 characters. All right, up to that 128 characters. With the catch, you'll notice this if you've been pressing space at all, because it's not as smart as Python in the sense that, you know, when you say input, it will gather all of the input and then give it to you. It does not work the same way here. In here, this is going to get all of the input from the user until it sees a space. Until it sees a space. If it sees a space, it's going to stop getting input and it's going to shove that into the buffer. If we rerun this, we'll see, you know, if I do FFFFFF for a long time, all of that will show up right here. But if I rerun this and I do FFF space and then a bunch of F's and rerun this, you'll see only 3 F's show up. All right. Do Mac users need to use scanf_s? No. No, I don't even think that would be available for you guys. It's a Microsoft's explicit thing, right? You guys will most likely only have access to scanf. And so, for example, if you do scanf_s, you'll see the first thing that pops up is a Microsoft doc link. All right, this is because it's a Microsoft specific version. All right, and pretty much you won't really see this anywhere else. Looks like there's some info here. This is for scanf, not for. Oh, yes, that is the one we're doing. This is for SSScanf. This is for SSCANS. This is for C++ reference. Where is this? Maybe this is the universal function they added. Sorry, I don't stay that up to date with my C/C++, you guys, so please forgive me. If it's available for you, then you should utilize it. If it's not, then just don't worry about it, right? Don't worry about it. That's not the main point we came here to CLAN for, right? That's not the main point we came here for CLAN for. We came here so we can learn about pointers a little bit, but we first got to go over the basics here and show you guys how things are the same. No, I can't use it on Mac. Okay, that's what I thought, but that document had me questioning things a little bit. All right, C is in the lower level languages. When you get to C, assembly, I can't really speak on Rust and Golang on their docs. You'll find things are kind of inconsistent, and it's kind of hard to learn these languages. The best way to learn them would be books, to be honest. And we're working on our pipeline for C development right now because it's kind of a half forgotten skill set. All right, it's really, really needed, but it's very niche, and the only way you can really learn it well is from being hired in a company that will teach it to you, which is kind of sad overall because it's kind of hard to recruit new people into it because you have to spend all this money and time training. But regardless, let's move on here. So, input from the user. If you're using normal scanf, you don't need this third part here. You don't need this third part here. So that's how you can input from the user. Remember, spaces will break this off. The only way to address that is you need to have more %s's here, potentially. There's another way you can get input from the user, all right? This was with scanf. There's another way you can do this, and that's going to be with this thing called getChar. getChar will get you a char. It will get you a character, and then it will tell you what that character is. All right. I think there's also one called. Oops, I gotta add my get. Is it just get C? Yeah, there's this one. And then there's get FC, which is also a good one. I think we can do this one and then do standard in. So the big thing for this is, remember those return values? Those are like report card reports that you'd get back that I was talking to you guys about. This will get a character from the command line and then it will return it to you. All right, it will return it to you. So if we say buffer and the first character in buffer is going to be equal to the getChar, if we save and rerun this, we'll see it's waiting for our input. Let's enter a bunch of input here and press enter. And we're going to see that the A has moved over. The A has moved over and been added to it. We're getting all of this output because we have no null pointer. We have to add our own null pointer. So you'll see the same thing if we just print our buffer right now, because there's no null pointer by default. So scanf is really nice because it will add a null pointer for you by default. If you're not using scanf, you may have to add that null pointer to end the screen, end the string, or else you will run into issues. All right? Because again, there's no hand holding here. There's no assuming. No one knows nothing. It's very dumb, but that also means you have more power. So we could add a null pointer, or sorry, a null byte by saying 1 is equal to /0. And when we rerun this, why are you being mad at me? Oh, it doesn't like the double quotes. It wants single quotes. Remember those single quotes, you guys, for characters. If we rerun this, you'll see we no longer get that weird output. Now we just get F. Now we just get F. And get C should be the same thing, except for get C, you can specify where you want to get your input from. It will accept any type of file pointer. So in this case, we're getting input from standard in, because your input from the terminal is basically its own file, and we want this to be equal to buffer 0 also. Equals, and we need to set this. Hopefully this works. There we go. Works just fine. And you'll see we get that. And it will only get one character. It will only get one character. This is another way you can get input. This is a potentially safer way to get input. All right, potentially safer way to get input. Why is it a safer way to get input, you ask? Because you can have them type in a bunch of input and you can get it one character at a time and kind of clean it on the way. But also you can be counting how many characters there are and do a bunch of cool, various stuff. And additionally, this will also handle spaces. And we'll show that all here in a little bit. All right. So there are 2 ways, technically 3 ways you can get input from the user in C. And there's a lot more. So we won't really worry about that for right now. But we now have a way to get input from the user, do we not? That's the important thing here. We have a way to get input from the user. So from that, we can then make something like our guessing game. We can recreate our guessing game. So what was our guessing game again? Let's recap it, and then we'll continue and we'll remake our guessing game in C here after the break. So our guessing game was a game where the first version of it had a hard-coded value. A hard-coded value that the user had to guess. And they kept guessing and guessing and guessing until they got it right. The first version of it that we made was with if statements only, and they only had one chance to guess. If they got it wrong, the program would end. If they got it right, it would tell them they're right, and then the program would end. We had to add a while loop in it to keep the game going until they guessed correctly. We can do the same thing here. All right, we can do the same thing here. So we're gonna recreate it. We might even go over while loops because you guys know what while loops are already, and they're the same way in here as they are in Python. So after the break, we're gonna go ahead and recreate that game now that we know how to get input from the user. All right. If you guys have any other questions, comments, or concerns, ask them while we're on break, and we'll continue when we get back in 3 to 5 minutes. All right? All right, I'll see you guys in 3 to 5 minutes. Alrighty. Let us continue on in our journey here. And all I gotta say is everyone developing on a Mac on Xcode right now, look, that's peak of a developer experience, right? Xcode is beautiful. It's always been beautiful. When it first was, I guess, gained a lot more popularity when the iPhone and stuff came out, because I believe it was around before that for normal development of applications. I guess it came out way before that. It's just so good. It's so good. It's so beautiful compared to VS Code. It's been like that for years now. Let me pull this up. Like, look how simple this is. All right, look how beautiful that is. You just play button right here for your files and other views. And then when you're typing, it brings up this. It tells you if it's a function with those Fs. It tells you if it's a defined item with those pound signs. And then when you press tab to auto complete something, it auto puts the parentheses for you and then tells you what you need to fill in next, which is a const char pointer, which we'll get into tomorrow. Don't worry about it. You're going to have fun with that. All right. And you can press tab to auto fill it in, and oh my God, it's so beautiful. And you can, I believe you can long press on the items to bring up the docs for it automatically. Because on here you have to right click. This is just going to the definition. I I don't even think this brings up the docs, but it's just so good. All right. Apple knows a thing or two about development, but we shall continue forward. Before we do, let's just recap real quick. We're a nonprofit named Rootkit here in the US of A. Look at that. The site is back up. All right. We're a nonprofit here in the US of A. We do a lot of things for free, including teaching guys for 100 Day on how to get our certification. All right. Don't go to college. Do not go to any other boot camp. All right. We're doing and teaching you everything they're going to teach you in college and more in 100 days so you can get our CompSci cert and then get a job. All right. It's not even a competition out here. We're just way ahead. I can't express how game changing this is. On top of all that, on top of all this free stuff we're doing, if you go over to our blog, all right, if you go over to our blog, you'll see our week 9 giveaway is now live. You can click on that and enter to win. Just press the green button here and just prove that you're subscribed to our YouTube channel, following our Twitch, etc., etc. You'll automatically be entered to win our giveaway, which we'll be pulling every Sunday. We do a giveaway every week, and it's a mystery item. So we'll pull what item that's going to be this weekend too, live in front of you guys. If you like what we're doing, because doing stuff for free is very, very expensive, you can click on the link in the description or on the Twitch chat in the about us somewhere. Excuse me, about us somewhere, and you can donate to help us out. All donations are being matched 1-for-1 for the first 10,000 donations. Additionally, depending on how much you donate, you can unlock certain rewards like our stickers, our collab t-shirt, and our epic sweater. All right, I got it on right now. Has 100 Day of Rootkit branding, our exclusive little mascot, and the Rootkit logo on the back. And we have pillars that we're hitting along the way, like streaming for 24 hours straight, shaving my head here live on stream, and the one no one wants to see, so it's the goal for us not to hit that goal, shaving my beard here live on stream. Alrighty. I don't see... I'm on Mac, I'm on Xcode, because Visual Studio doesn't work on Mac. Yep. Visual Studio... yeah. I don't like using Visual Studio. I don't use it much. Most of the C development I did was not using Visual Studio. It was pretty much doing it in Atom. This was before I made my switch to VS Code, and then using the native GCC compiler directly. All right. So forgive me if we stumble through Visual Studio here a little bit. So let us continue here. All right. We know arrays, we know variables, we know printing. We've learned a couple different ways to get input from the user, all right? And we know we can do if statements. I hinted that we can do while statements. So let's try to recreate our game, shall we? All right, let's try to recreate our game. It's gonna kill me if I don't figure out how to auto do comments here. I know it's, where the hell is it? Because I wanna comment this crap out. I'm gonna fucking just kill this goddamn thing. I'm so angry. I really do hate Visual Studio. I'm so sorry. I like it because it can be really good, but also I just really, really hate it. Where is the commenting? Where is it? That's for formatting. Oh shit, what have I done? It's literally like K, but there's, is it Alt? Is that what I'm missing? Toggle comments, Control K. I literally did Control K. It did not work. Okay, whatever. We're moving on. All right, we're moving on before I shoot my computer. All right. Alrighty, let's make our game. I'm going to comment all this out so we don't get interrupted with it. We're going to start from scratch, and by scratch, I mean, I'm going to just push this all down so we don't have to look at it anymore. What do we do as devs? We steal. That's right. We're thefts at heart. So let's steal from ourselves, shall we? So let us bring up our old code here. Let's pull up our old game. All right, so 100 Days of Rootkit. And let's look at our Python code and directly translate everything. Here's our guessing game. All right, this is a newer version of our guessing game where we were taking from a word list. Let me go in and zoom in a little bit on this. See, why can't, just for the love of God, why can't you just make the shortcuts the same on both of them. It doesn't make any sense. All right. So let's look here. All right. We have a while loop, which is our game loop. But at the beginning, we don't need to have it as complex. So we're not reading from a file anymore. So since we're not reading, hold on. This is the word guessing one. Let's go to old. Where's our number guessing one? First game. Here we go. Sorry about that, you guys. I'm just so disturbed right now. Okay. Whew, let's do this. All right, let's do this. All right, we're gonna ignore random right now. All right, we're gonna ignore random right now. We need to choose a number, a predetermined number. So the number they need to guess. All right. So we're gonna do our guess number, and this needs to be equal to something. Let's say 5. All right. Remember, you need to say what that number is going to be. We can just say it's going to be an integer. All right. So this is the number they're going to guess. Next, we have to collect users input. We can see here we have users input equal to 0 by default. Here, we don't have to give it a 0. We can just define user input and put a semicolon at the end. So we can do int because we want them to give us a number, user input, and we can just do a semicolon. By default, when you just initialize a value like this, there will be null values in it. Right? It will be equal to null, none, which in some variables that will be the equivalent to 0. It conveniently is the equivalent to 0 for integers. Next, look at our code. We have a while loop. So we need a while loop in here. We haven't talked about while loops. We don't know how to do while loops technically in C. Well, we can kind of guess, or we could also look up. While loops follow the same format as our if statements. It's going to be while, then parentheses, and inside those parentheses, we do our logic, and then afterwards, we do our curly braces. So we're going to say while, and oh my god, IntelliJ worked that time, or intelligence sense, or whatever it's called. All right, it didn't work for any of those other times, but now it decides to work for a while. It's because I heard I was talking all this crap. Oh god. This is the format of your while loop. All right, this is the format of your while loop. Just like the if statements, there's absolutely no difference. And then in our while loop, what do we put? Well, let's look at our first game here. We want to keep playing the game forever until users input, we want to keep playing the game forever while the user's input is not equal to the number they need to guess, aka this guess number. So we can recreate the same thing here. We can say user input not equal to guess number. Look at that. We're pro C programmers. We're directly translating our Python code into C. All right. This is mad at us because what it's saying right now is that we have uninitialized memory. All right. So it's saying it's not equal to anything right now. So it's best to give it some type of initial value here. So we'll go ahead and have it equal to 0 so it doesn't get mad at us. So we'll get rid of that little, anything that you see in green underscored or underlined squiggly wise is a recommendation typically. It's not required. It won't cause an error typically in your program. All right. So let's go ahead and move on here. We need some input from the user and we want to print out that they need to choose a number between something and something. All right. So to do that, we had our lowest and highest number, and this was what would be printed out. So we can make our program more dry. We can copy the same thing. We can say this is going to be our lower bounds, and let's say we're guessing between 1 and 10, and this is going to be our upper bounds, and this is going to be equal, 10 and 1. There we go, 1 through 10. All right, so we can do the same thing here. And when we print out our message here, don't forget those semicolons, right? We can print the same message out. Let's just copy this exactly how it is from our Python program here. And let's go ahead and say print F, parentheses, and we'll put our code right here. Except now we can't do the brackets. We have to do the %i for integer values because we have our integers here. So let's go ahead and do %i and then %i. So we have, let me go and make this big for you guys. So we have our integer values here. So you guys may have been asking, if you haven't already tried this out, how do you add multiple variables to a string? It's easy. Just add more add more commas. Yes, commas. So the first one is going to be our lower bounds because this is just like format, exactly like format in Python. Depending on how you put them in here, it's going to read it from left to right, just the same way it does here. Left to right for the variables for inserting. So we'll do upper bounds. Remember that semicolon, and bam, we have a functioning program. All right, this will currently run forever. We don't want that. But we do kind of want to test this. We've done a lot of programming here. We don't know if this is working or functional. So let's test this. Whoa, wait. You're a little crazy. All right, it's a while loop. And this program language is faster, more optimized. You're really going to ramp up your CPU running this. It's going to be quite chaotic. All right, so let's just run this once. You can run this once by altering the logic right here, but remember we learned about this thing called break, which is a way to forcibly end the loop. There are breaks also in C. So if we type in break and then do a semicolon, this will start the loop. It will then do this print statement, and then right after printing once, it will see break and immediately break out of the loop. All right, it will break out of these little, think of it as breaking out of these brackets here. This is more visually appealing than the Python version where it's like you're breaking out of that indented up inside the while loop. This is more visual because you're literally inside of these two curly braces here. So you're kind of breaking out of this. Same concept, a little bit more visual here in C. So if we run this, you'll see that everything's working great. We have enter a number between 1 and 10, gets printed out. Everything is working great so far. Any questions before we continue on? Doing one's more for AMD means two files have the same name as main. By the way, I'm ashamed to say it took me all of class to figure that. Yeah. Make sure that there's only one main function, right? Only one main function, because this is where it knows to execute. So if you have multiple mains, you're going to run into collision issues. That's a great thing to bring up. All right. So let us trek on forward. So we have our while loop here working. Our print statement here is working. Next thing we need to do is get our input, right? So let's get our input next. We don't need to do casting into an integer here, right? Because when we use something like scanf per se, it allows us to straight up get the value and put it into the corresponding variable. All right. So I'm going to keep the break right here so we can do some testing. So let's do a scanf _s if you're in Windows. And then in here, we want to do %i because we want to get an integer value, and we want to store that into the user's input. All right. And just to make sure all of this is working, remember we got to do comma, and we'll accept up to 2. All right, 2 items. I don't know if this is byte data. Non-pointer, okay. For this, what are you yelling about now? Extra argument. Oh, now you don't want that? Is it only, okay, well, okay. You don't add that extra item, I guess, for integers for the secure version. For macOS and for Windows users, you guys will need to add this ampersand sign in front of user's input. Why? This is a teaser into pointers. We'll talk about it later. Don't worry. Just do it for right now. All right. And to make sure this works, let's just do another printf. And let's do %i here. And let's print out user input. All right. Let's print out user input. All right. So again, we're printing this. We're getting input from the user, and let's add a new line at the beginning of this, and then we're just printing out what we got from the user, right? And then we're ending our loop immediately with this break, just to see if we have this working. So let's run. Let's say we choose the number 3 and press enter, and we see the number 3 get outputted out, which means we're on the right track. Everything is working successfully so far. We are successfully copying our Python program over. So the last step here is going to be our if statements. Our if statements. We need 3 if statements. You know what? I'm just going to copy the Python code directly into C so we don't have to go back and forth. And we can straight up just convert this. All right. So our if statements now are going to be if, and then are going to be in this syntax. Remember, again, your logic in parentheses and the code that you want to execute when the if is true inside of these brackets. So we can copy this logic here from our if statement, put this in here. We might need to change some logic though, because we don't have these variables called highest or lowest number. We have them called lower and then upper bounds. So let's change that. And remember, there is no or for us to utilize, so change that to your 2, your 2 pipes. And then we have our print statement down here. Remember, we have printf instead, so we'll do printf. And we can go ahead and copy this exact string straight from Python right here. And instead of those brackets, we're going to do %i, and then %i, and then we're going to do lower and upper bounds. I'm going to steal that from our print statement here up above. All right. We've completed this. Remember your semicolons. Look at that. We're translating. We're doing it. We just got to add 2 more else ifs, and we've pretty much recreated our first program here in C. All right. So let's go ahead and do else if, and then we'll do our parentheses and then brackets. In C, most people, there's 1 or 2 people. All right, there's 1 or 2 people when it comes to these curly brackets and where they're placed. All right, some people prefer them to the first one to start right here after your parentheses. Some people want it like this. It is up to you and personal taste. All right, it's up to you and personal taste. I don't really care. I think both are fine. I think both work. And since Microsoft in here is encouraging us to do it like this, I'm going to keep it consistent moving forward with the layout like this. But it's totally up to you. For our elifs, I'm going to do the same thing. I'm going to copy this logic we had in Python, paste it in here. Number they need to guess is now called guess number. So I'm just going to replace that. And then we have a print statement inside of it called you guessed too high. I'm just going to directly paste that, change print to a printf, and then add the semicolon. And we've done the conversion for that one. And we have one more elif. So let's just do else if. And it's the same, just a print statement, change print to printf, and then put the semicolon at the end. I can now delete all of this. And we can delete this. And bam. We have now created our game. Wait a second. Why is this set to true? We forgot to copy the logic for that last one. Let us copy the logic for this last one, because we forgot to do that. And this needs to be guess number. Now we've completed our game. And let's remove the break here because we don't need it anymore. So congratulations. you've now completed your game and converted it from Python to C, and pretty much it's pretty much the exact same amount of lines of code. Technically slightly more typing because you have to do all the semicolons and the brackets and etc. But you've now converted it. And I hope you guys are kind of seeing the picture here. When I say you learn one, you learn them all. Because you learn one language, you learn them all. They're all the same at their core. They are all going to have variables. They're all going to have if statements. They're all going to have while statements. Potentially for loops. For loops are... Sometimes they have just while statements. Sometimes they only have for loops. Regardless, you can do the same logic as for loops / while loops in pretty much all the languages. They're going to have a way to print. They're going to have a way to get input from the user. All right? They're going to have a way to do logic. They're going to have functions. Not all of them will have classes. There's no classes in C. It's a purely functional programming language. There's no objects. If you try to do dot notation on these, so if I say like user input dot, nothing will come up because these are not objects. The closest thing you get to objects in C would be structures, which we'll hit on a little bit later. Don't worry about it for now. All right. If we run this, let's go ahead and see our game in action, shall we? So enter a number between 1 and 10. Let's go ahead and enter 1. And we press 1 and it says you guessed too low. Enter a number between 1 and 10. You'll see the printing is a little messed up, because printf again doesn't add that new line. So the quick fix around that is going to be at the end of our while loop. Let's go ahead and just do a printf here with a /n. All right, with a /n. So that way we get that new line. So let's rerun our game here. And let's say 2. There we go. Looks quite a bit better now. You guessed too low. So let's guess higher. Let's guess an 8. You guessed too high. All right. Let's guess a number out of the bounds, shall we? Let's guess a number like 20. It says you need to guess a number between 1 and 10. So that is working. Let's guess something like -20. That is also working. It says we need to guess a number between 1 and 10. Looks like everything's functional. The last one we need to do is guess the correct number, which we have hard-coded as 5. Let's type in 5 and press enter. And look at that. The game ends. We've successfully translated our game. We have it functioning. And we did it in C. One of the most impressive languages. The most hardcore, low-end, impressive languages out of all the languages that are available according to some. All right? And it looks almost identical to Python code. Because Python code is pretty close to C. Because guess what? It was built on C/C++. So it has a lot of shared similarities. Any questions on this? Any questions on this? Any questions on the syntax, on the conversion, on any of the nomenclature we've gone over? Anything here? Oh, that's why. It's always pushed at the bottom. I was confused for a second. I was like, where's my ending curly brace? Again, we're really breezing through this on these streams because we've already gone over this stuff. All right? We've talked about this stuff. You guys should already know this stuff. We've covered in Python. It's nothing new we're introducing. Syntax is slightly differently. Additionally, I've done at least one recorded stream, I believe, before. Let me go to live for C. Did it not get recorded? I guess not. I thought it was recorded. I guess not. The last one I did on C was much, much better than our presentation right now, I personally think, because things were a little bit more formatted, right? We're kind of going about it as in a more exploratory nature, so we're running into issues and stuff. I don't have things pre-made right now. So that one I guess not recorded, has a lot of pre-made stuff that we go through and execute and show off. So I was trying to look for the files for it before we started, but I couldn't find it, unfortunately. I'll look some more because it's a really good layout that I had. Any other questions here? Yeah, Kamal, scanf_s will not work in Mac. It's only scanf because this is more of a Windows exclusive thing. Yeah, the most difficult thing for going in between languages is definitely going to be syntax, because like if you're coming from C and going to something like Python or JavaScript, I guess JavaScript will handle semicolons, but you know, you'll add semicolons and it won't like it and will yell at you. And then when you're going from Python to something like C, you'll forget the semicolons a lot and it will yell at you. That's pretty normal. All right, that's pretty normal. That's not a big issue. All right, that's not a big issue. So if you have any questions, please ask them. I'm going to start wrapping up. Ask any questions you have last minute. So tomorrow we're going to talk about pointers. What pointers are. You guys have already seen them in Python. We're going to get more in depth with them here. We're going to talk about their pros. We're going to talk about why they even exists. There's not really, I mean, there's cons to it also, I guess we'll talk about a little bit, but overall, there's not really too many cons. There's mostly just pros. And let's see here. Yeah, tomorrow's just going to be for pointers, all right? Pointers. You've technically already been using pointers here in C, specifically when we're talking about arrays. And here we're dealing with pointers also. All right. So we're going to do a lot of exploration with them. All right. A lot of exploration with pointers. Any questions right now before we end up ending? So your guys' assignment. All right. Your guys' assignments today. At the end of stream, I want you guys to go through some of the old files that we've made, programs we've gone through, and I want you guys to try to, not this one, wood alter, score reader, here we go, our singing game, all right, our singing game. So our singing game where we're singing Old MacDonald Had a Farm with some animals, right? I want you guys to try to recreate this in C, right? Try to recreate this in C. It most likely will be easiest if you guys have the animal pairs as two different arrays. Here we have them as one array where both items are together. It will most likely be easier for you if you have them as two separate arrays. All right, or it may be, hold on, let me test this real quick. Char array, will this even work? I don't even think this would work. I think you'll have to make a double array. Yeah, do it with one word. Do it with one word, all right? I don't want to break your guys' head right now, all right? Do this with one animal and one sound. All right, one animal and one sound. Your extended assignment, if you really want a challenge, try to figure out how to do it with an array of strings in C. All right. So one animal, one sound. Print the lyrics to Old MacDonald. Right. Print the lyrics to Old MacDonald with one animal and one sound. Right. That's it. That is your guys' challenge after this. And then tomorrow we'll get into pointers, which will also help us unlock the discovery of having multi-dimensional arrays, because they're they can get kind of funky. All right, we're getting into Funk Town here soon. Alrighty, I don't see any questions coming in, so we're gonna call that a day. I will see you guys tomorrow on the next one.